Alright, number 22. Oh, let me find it first. Where are we? 22. Ah, that one, okay. Well, let me do this. Come on. There we go. Alright, let's move this. Let's get a circle. Let's copy it. Paste it. Okay. And let's put some stuff in there. Got a chord about right there. Now, on this one, I believe they left something out, unless somebody can show me otherwise. Is that what it looks like? Yeah. There's one down below between this, right, between this one and this one. And that's what we're trying to find, isn't it? That one right there? Okay. And let's put some letters in here. This is MLN. I think they left you to assume something, which is not a good thing. They should tell you stuff. Unless somebody can tell me otherwise. This is J. Alright, here we go. So we're trying to find LN, correct? And what else does it say? It says MN is 16. And I'll write that down. MN equals 16. And I think that's all they tell you up there. Oh, they tell you an angle. Angle, or arc MLN. MLN. Arc is, what is it? 98 degrees. I don't think we really need that one, though, to solve for LN. But we'll put it in there anyway, because I think that's for number 21, where you had to know the arc. Alright, well, let's take a look. Here we go. We finally got it written down. We're trying to find LN. Let's make that a different color just so it stands out a little bit more. Okay, so that's what we're trying to solve for. Is that really... Can you see the difference between that color or not? There we go. That's a little better. So we're trying to find this one right here. Now there's a thing in our a theorem in one of our lessons, and it even tells you what lesson this is from, doesn't it? 10.3. So if you go to 10.3, it talks about a diameter and it talks about a chord. But let's go back to there. Everybody got your book out? Let's take a look at 10.3. I'll flip back and look at it if you don't have your book. And I believe they're missing something here. They should tell you. So the one that deals with this, yep, the one that deals with this is a diameter. It's on page 702 if you want to follow along. Look at it. Unless you see a theorem somewhere else in that chapter that I'm missing, and I don't think I am, but I could be. It says if a diameter or radius of a circle is perpendicular to a chord. It says if a diameter is perpendicular to a chord. What's the problem on this, though? They don't tell you, do they? All right? But I think they should have told you, or they're making an assumption, and they should not make an assumption. Okay, they should tell you that this is perpendicular, and I don't think they. I think they should have. So I'll blame them. Is that all right? I blame them enough, don't I? Even though it wasn't their fault the other day. Remember that one? That was my fault. But then it says it bisects the chord and its arc. So that should help us out a little bit. It bisects the chord and it bisects the arc. So really what I'm concerned about is the chord. So remember, MN is 16, isn't it? From M all the way to N. If this is perpendicular, again, it's not my fault, but they should have told us that that was perpendicular. All right? I don't know if that was where you went wrong on this. You're like, well, wait a minute, they don't tell me it's perpendicular, so I can't say anything about it. And if you did say that, then that's a good thing, all right? Because at least you looked at it and recognized that I need to know that that's perpendicular to that chord. And I don't, so what can I do? I can't do anything with it, all right? But on the other hand, they do give us an answer, so we probably are leaving something out, and that's the writing. Okay, I beat that to death. Let's do it now. Since we know it's perpendicular, I'm telling you right now it's perpendicular. Okay, so MN is 16. So what did we say about that diameter? What does it do to that chord? It bisects it. So what is like PN? What would that be equal to? That'd be 8. And what would MP be equal to? That would be 8, right? Split it in half. No big deal. Now it also splits the arc as well, but on this particular problem, we don't really care about that. I think on number 21, you would use that one, but on 22, you really don't. So let's see. What are we trying to do? We're trying to find this pink or purple chord right here. Is that enough to help us out? Well, we do know the radius of the circle, don't we? We know the radius is 10. Does that help us out? Does that help us find this one right here? No. So what in the world? We don't have enough information. I know one side, but then these two sides I don't know. So what do you think, Travis?
I drew a radius from K to N and made a triangle.
Good. And that's, you got to think outside the box a little bit. All right. Just because they don't have this thing drawn, we've done this before. When we first did this lesson, we did this several times. So we're going to have to make a triangle out of it. And we're going to have to draw our own other side. So you have to think about that a little bit on this one. Even though they do have a triangle, that PLN, even though they did draw that, that's not really the triangle we're going to use. Because if you look at it, I only know one side of that right triangle. I don't know any angles, so I'm kind of stuck. I can't do anything with that. So what I'm going to have to do is make another triangle. So how's that going to help us? Well, let's draw it and let's see. So if I draw from K to N, now why would I even think about drawing from K to N? Well, because I know the length of KN now. So what is the length of KN? It's 10 because it's a what of the circle? It's a radius of the circle. Do you see that? KJ is a radius, it's 10, so KN is going to be 10 as well. Does that make sense? Does that help us? Well, I've got a right triangle. See this KPN right here? This one that I'm kind of tracing over? That one right there? I know two sides of this, don't I? And it's actually kind of a special triangle, isn't it? Makes it kind of easy so I don't have to do all this math. This is, I don't know what this is. We'll call it X. I've got X, 8, so don't know, 8, 10. Does that ring a bell at all? Last chapter? It's a 3, 4, 5, right? And you say, well, wait a minute. I don't see a 3, a 4, or a 5. But this is 5. This is twice a 5, or 2 times 5, right? This is 2 times 4, so this must be what? 2 times 3, which is 6. So this little segment right there, did anybody figure that out on their own? So that right there would be 6. Isn't that a lot easier than coming over here and doing Pythagorean theorem? Yeah, it wouldn't be hard. If you didn't realize it, I'm not saying that you have to look at it and recognize it's 3, 4, 5. But I'm just saying, guys, I'm just saying that it's a lot easier, it's a lot quicker, and I didn't have to do any math. I just recognized it's 3, 4, 5, so that has to be 6 right there. Now, again, what are we trying to do, though? That's not what we're trying to find. What are we trying to find? This pink one right here, purple, whatever color that is. All right? We're trying to find this one. How does knowing that this is 6 help us find ln?
LP is 3 or 4.
It's 4, right. LP right here is going to be 4. Okay, again, how does that help us? That still didn't find ln for us. Now I got two sides of this right triangle. Remember at the very beginning I looked at this and I said, okay, well I know this is 8, but I don't know what this is and I don't know what this is. All right, so there's no way I could have found it. But now going through all this other stuff, I figured out what this is. Did you understand why this is 4, by the way? I didn't explain that, but hopefully you did. Remember, from K to L is the radius, so it's 10. Took 6 away from 10, and I got 4. Does that make sense? Okay, so now I have a right triangle. Now this is not a special triangle, so I can't go it's 4, 8, whatever. So I'm going to have to do Pythagorean theorem with this. All right, and now I can find ln, and that should give us our answer. So we'll call ln, I don't know, just call it what? Just call it x. All right, I erased that x up here, so we'll call this x. So what do I got? I got x squared is equal to 4 squared plus 8 squared, and whatever that comes out to be. You do that, you take the square root, right? And then square root of 80, is that right? 16 and 30, or 64, is that 80? Okay, square root of 80, and there you go. So let's see. If you wanted to, let's just do this for fun, all right? Because you'll have to do this in algebra too. This is 8 times 10, isn't it? 80. So break this down. This is what? 4 times 2, right? And this is what? 2 times 5. So look what we have. What's the square root of 4? This is all under square root, by the way. It's a 2. And what's that? That's a 2. And then you're going to have a square root of 5. Remember, this is all under square root right here. So it's not 2. It's what? It's 4, right? Square root of 5. Now, the book doesn't require you to write it like this. In Algebra 2, you're going to have to go through this and simplify it. I just, every once in a while, I want to throw that out to you so that when you get to Algebra 2, at least it sticks in your head just a little bit. All right? But you could just put this into a calculator if you wanted to, and somebody tell me, I don't know what that is. 8.9? All right. I'll trust you on that one. And that would be your answer. That would be ln. So there you go. That was definitely probably the definitely, probably. That was definitely the hardest one, don't you think, out of the whole thing? Yeah, because you really had to do several steps on that. You had to think, again, like I said, a little outside the box, where you had to draw that radius right here. And then you had to find the length of one of these sides of the triangle, which helps you find this side of the triangle, which helps you find the hypotenuse with the Pythagorean theorem, okay? There you go. So that's good stuff. I enjoy that stuff, don't you? Isn't that kind of cool? It's almost like it's like a mystery, you know? You don't know how to find it, and you find one clue to find another clue to find another clue. And then finally, it all comes together, and we got it. Nobody shares in my enthusiasm for this? No? It's like a national treasure, right? Like the movie National Treasure. Nick Cage, right? Gotcha. All right, well, enough of that one. What else do we have to do? Which one did we do? Let's see. Let's go 28 and then 34. All right, so 28. Let's take a look at 28. Let me find my... let's see, 28. All righty. Draw this thing out like this. We won't make it too big because I got some lines to draw here. Looks like you got a tangent coming this way, don't you? Does that look tangent? Actually, it's tangent to both of them, isn't it? Tell you what, I'm not going to write that one first. Let's do this. Let's write a tangent here. Let's kind of scooch that up a little bit. Okay, and then from here we're going to do another tangent. About right there, and it stops right on the circle. And then let's take this and just extend it out a little bit. Looks like it's a little bit longer in the book. And this goes to the center, and this one goes down to this tangent. Okay. Wow, that's crazy looking, isn't it? Alright, what's it tell you? It tells you this little bit is 39. Tells you this little bit is 41, but look what they did. Now, I like to do this little thingy. Okay, that whole thing right there is 41, right? From the center all the way to that point outside of there. This little bit is y. This is 5x minus 8. And this is 72 minus 3x. Alright. And we're trying to solve for x and y, right? Okay, what do we have? Well, let's see. Oh, okay, here we go. Look, it says that's tangent right there, and that's tangent right there, because it probably says if it appears to be tangent, it is tangent. All right, so we're not really assuming anything, are we? They're telling us if it looks like it, it is. You got it? Okay, as far as the tangent. So yeah, that looks like it, and that looks like it, so it is. They tell you that. So if you have a point outside the circle, and this goes to the tangent of the circle, and this goes to the tangent of the circle, what's true about those two segments right there? They're equal to each other. That's right. Okay, that's one of our theorems, and you just have to know that. So that should be pretty easy, right? So it's 5x minus 8 is equal to 72 minus 3x. That was pretty simple. You should be able to do that. And so what do we get? Add a 3x, you get 8x. Add an 8, you get 80. X is 10. Is that right? Yep. Okay. So that was the easy part. What about y? Okay. Now, do we have to assume? Are we making any assumptions about this? We're really not, because we have a theorem that says something like this. Now, you could look it up. I'm not sure exactly where it is, but it's in there. We're on section, what, 10.5. So you can look up 10.5, and there's a theorem that says this. If we have a radius or a diameter, and it's drawn to the point of tangency, and it is, isn't it? Do you see that line right there? It's tangent, isn't it? If it's drawn to the point of tangency, guess how it hits it? It hits it perpendicular. Okay? So we're not making any assumptions about that. We know that it is perpendicular right there. And now it's just Pythagorean theorem, and I got y, so it's no big deal. I don't have to go through all the math there, do I? I'll just set it up for you. Y squared plus what? No, 39 squared equals what? 41 squared. Remember, the hypotenuse, which is opposite the right angle, always goes out here by itself. It's the two legs that are squared and added up. You can do the math, and the book says it's 12.6, so you should get that. All right? That wasn't so bad, was it? That was a lot easier than the other one we did. All right. Which number was that one?
28.
28. And what are we doing now? 34. Okay. Alright, let's change colors here. So 34. Let's take a look at that one. Alright. Alright, it's like this guy's digging a hole. He finds this saucer, this plate, basically. But it's kind of broken. And we're just finding the, like one of the arcs to the plate. And so what they do is they basically, I'm going to start with a whole circle here and just draw an arc right there. Alright? And what else? They give you that perpendicular line, don't they? Watch this. From the center here. But they don't actually draw the line from the center. They draw it to here, and they actually tell you that this is perpendicular. So that was nice of them. What else do they tell you? They tell you from... They basically tell you that this is 2. They don't draw it like this in the book, but if you look at it, they have this line that comes up here and a line that comes up here, and they say this is 2 and this is 2. But that's the same as saying that these two are both 2. Make sense? And they should be equal to each other, right? Because if this is perpendicular to this chord, then it splits that chord into 2 equal chords. All right? Or not chords, but segments. Where am I? What else are we trying to do? What was the circumference of the original saucer? And it also tells you this little length right here is 0.75 inches. All right, so 0.75. So they're asking, what is the circumference of the original plate or saucer, whatever they want to call it. So we're trying to find the circumference. Basically, I just drew the original one, didn't I? Because it was kind of broken here. They found this information, and they could find the circumference of this whole thing. Well, that's kind of interesting. Look, even if you didn't know what the whole radius was or all that, but you could just take a part of this that was broken off, right? You understand what I'm doing? From here to here was broken off, and you could figure out that this was perpendicular to this. You could find the whole length of that. It's really not that hard to figure it out on your own. You could find the circumference of that whole entire circle. Well, hopefully we can. Let's see if we can or not. How in the world are we going to find the circumference? Well, we need a formula, don't we? What is it? 2 pi r, or we could say what? Pi times the diameter, whatever we're going to use here. So what do you think we're going to eventually try to do here? Try to find the what? Yeah, I would probably go radius, wouldn't you? I don't know. You want to go diameter? I think, did you find the diameter first, or did you find the radius? Did you? I don't know. I haven't even figured it out in my head yet. I'm gonna have to start doing some stuff. I'm gonna take this just down to the radius right here, and then I'm looking at this. Go ahead.
You do 2 squared times 0.75 is the whole.
Oh, not x, plus x. Right?
I thought it'd be on both sides times.
Where are you drawing your triangle? You're drawing a triangle to here?
No,
What are you doing?
I'm telling you.
Go ahead, tell me. Oh, gotcha. You're right, the diameter. I wasn't thinking the right lesson. I was thinking using triangles, but you're absolutely right. Thanks, Travis. Come to the rescue again. All right. So watch what he's saying. Remember that theorem that says if you have 2 chords intersecting inside the circle, you take the product of this. Remember A times B equals C times D? Yes? Anybody remember that one? All right, that's what we're doing here. And so what we do, we call this whole thing right here, watch this. We call this whole thing, we'll just call it X. Remember the math on this? So you are going to find the whole entire diameter then. All right, well, you'll find this part and then add it to the 0.75, and then we're good. So watch what we do. We go this times this, so it's, let's do it down here, 0.75x equals this times this, which would be 4. Divide by 0.75. Somebody do that for me. Who's got a calculator? 5 point what? 5.3. Okay. So x is 5.3, but that's not our answer though, is it? This is x right here, 5.3. Put that in right there. What are we trying to do? We're trying to find the circumference, right? So if we can find the diameter, multiplied by pi, and we got the whole thing. Is that 5.3 the diameter, though? No, it's not. It's 5.3 what? Plus the 0.75. So it's 5.3 plus 0.75. So that's a 5, that's a 10, that's a 6. Did I do that right? So that's what the whole diameter is. But how do we find the circumference? See, the diameter is that. The circumference, just multiply it by pi. 6.05. And you should get somewhere around 19.1. Is that right? Makes sense, yeah, because pi is 3, right? Just a little more than 3. 3 times 6 is a little more than, right? So a little more than 18, 19.1. Yeah. So that's good enough right there, okay? There you go. So it's kind of helpful to know what lesson this was over, because you could always, does anybody do that on these study guides? Do you ever look back at the lesson? Because it tells you what lesson is covered, right? It's a good idea. I mean, I think it is. That you go back, and they even give you an example. That's what's nice about these study guides. They even give you an example right next door to it, which I should have looked at. Look at the example, by the way. Are you looking in the book? Example 7. That's like almost identical to what we just did right there. All right, so you have it right in your book. I should have looked at it. I didn't. But there you go. What do you think? That's kind of cool, huh? We got a couple minutes. Do we have one more? So like 37? Okay. All right. Last one. Oops. Okay, here's the deal. We'll forget that whole wood chopping aspect of it. Let's just do this. What they do is they say that this whole thing... Now, where does the 15 come into play on this? Oh, okay, her arm and... Right, thank you. It says her arm comes to... Actually, it doesn't... Let me switch this. Just find an empty seat. Watch this. Oops, sorry. Let's try this again. Let's grab it. There we go. So her arm comes to here, which is 19 inches, and then her hatchet is 15 inches, and that's not that hard to figure out. We all could have done that, right? So what is the whole length of her arm comes to here, and that hatchet thing that she's swinging around, which don't do this at home, okay? I'm a professional, so you know. So the hatchet right here is 15 inches. So what's the whole length from there to there? It's 34, right? So that whole length is 34. The question says, what is the equation of the circle? All right, so it was a lot to go through. This word problem was kind of silly, but basically the radius is 34. What's the equation of the circle? Now, we kind of have to make an assumption a little bit, I guess, right here. It doesn't say anything about our x and y axis, but you know, if she's swinging this hatchet around like here, where do you think the center of that circle is? Well, you kind of have to. It's not really an assumption. You just kind of have to say that this is 0, 0. We call this the origin. Okay.
I'm not gonna be here. If you're.
All right. So what we have to do, the hardest part about this is basically just figuring out that this is the center of our circle. We just call it 0, 0. Do you remember what the equation of the circle is? It's r squared equals what? X minus, what letters do we use? H, and then y minus k. Right, and that equals r squared, right? You could put the r squared on the right if you wanted to. So in this situation, it's pretty easy. What is the radius of the circle? Right, it's 34. So we go 34 what? Squared, whatever number that is. And this is, since we made our center of our circle 0, 0. What will we make this? It's x minus 0, which is x squared plus what? Y squared, and there you go. All right, you can just leave it like this. You can put the number in if you wanted to for 34 squared. I have no idea what that is. The book actually writes it 34 squared, whatever. All right, but you got a calculator. You could always put it in there. And that's it. It's pretty easy, isn't it? Equation of a circle? Yeah. It looked kind of weird. I think if you had a question with this, it was probably what in the world is the center? Okay, and I'd probably have that same question. And but we just make it 0, 0. All right, enough of that. And I'm going to give you a worksheet here in a second as soon as I get it copied. And then I'll let you do that for homework. It'll be our last thing for review. And then we'll take the test on Wednesday, and then corrections Thursday. So please be here Wednesday and Thursday so that you don't have to make it up some other time. No, I'll let you hang on to the study guide. So I'll collect it the day of the test. Okay, I always collect the review stuff from the day of the test. So let me do that.